Alright, we're going to try something new today with the black background. Let's see how it goes. Um, the 2.8, graphing inequalities, and it's not just graphing on the number line, graphing like we've done before, but in two variables. So first, you're going to graph it the same way you graph linear equations and all the other graphs. So we first have to get, for this one, we gotta get that y by itself and get it in slope-intercept form. So I'm gonna subtract x. 2y is greater than, I'm gonna put the x first, so it's negative x plus 6 and divide by 2. Now remember, all your rules still apply here with inequalities, to where if I'm dividing by a negative, I would need to change this inequality here. But this is a positive 2, so I have y is greater than, and this becomes negative 1/2 x plus 6. I'm sorry, plus 3. That 6 needs to be divided by 2 as well. Label your m and b. My m is negative 1/2. My b is 3. The b is the y-intercept. I'm going to graph that first on the y-axis. I still have some people making mistakes with that first part. It's not anything difficult. It's just what you need to remember to do. That you need to remember to do it on the y-axis, and you graph the y-intercept first and then use the slope. So when I'm using the slope, I'm going down 1, right 2. Make sure that's a negative slope, which it is. So I have my ruler set up. One thing, there's basically two differences that you need to pay attention to with inequalities rather than equations. We're going to shade one side of the line. So if you see my ruler here, it's lined up. I'm going to shade on this half of that line, or I'm going to shade on this half of that line. And shading is going to give me all the solutions for this inequality. But I also need to pay attention to the line. And just like when you have an open circle or a closed circle, you need to pay attention to the inequality, and that's going to tell you whether it's an open line or a closed line. Closed line. Anyways, so because this is not equal to, it means it's going to be an open line, which basically is just going to be a dashed line. It's not a straight filled in line. When it's dashed, that's the same thing as having an open circle. And from here, I need to figure out which side to shade. So you basically need to find the solution set. Is all of this the solution set, or all of this the solution set? Point? Well, I'm going to show you a shortcut in a second. The way you're supposed to do it is to pick a point and plug it in. You can pick any point you want. The easiest point is 0, 0, because what happens when you plug it in is it makes both the x term and the y term 0. So that becomes 0 is greater than 6, and that is not true, which means that this point that I checked, since it's not true, it should not be in the shaded region, which means I would need to shade the other part of the graph, the other side of the line. So I would shade all here. Now, the easy way to shade is you must, in order to use this rule, you have to get it in slope-intercept form first. But once it's in slope-intercept form, if it's greater than, shade up. If it's less than, shade down. Okay, so this is a word problem, and you have to come up with the inequality first and then graph it. So a recreation center offers various 30-minute and 60-minute art classes. The recreation director has allotted up to 20 hours per week for art classes. Write an inequality to represent the number of classes that can be offered per week. Graph the inequality. You first have to label your variables, and in this one you're going to have two variables. We're going to have the x and the y. So we're going to label the x the number of 30-minute classes. The unknown is how many of each class are there. And then y is the number of 1-hour classes or 60-minute classes. And together, there's only 20 hours per week. Now, it could be less than 20, so that's where the inequality will come in. But since this is a half hour, I'm going to do 1/2 times x. So half hour times the number of half-hour classes plus the number of 1-hour classes has got to be less than 20 hours. And that's going to be my inequality. Well, actually, I forgot to put the equal to here because it is allowed to be 20 hours exactly, just 20 or less hours basically. So what I'm going to do is put this in slope-intercept form. So I'm going to subtract 1/2 x from both sides. Why do I change my inequality? Good job. Nope. I only subtracted the 1/2. I didn't divide by a negative. So y is less than or equal to negative 1/2 x plus 20. And now I'm going to go ahead and graph it. I'm going to cover up a little bit of my work, but then I'm going to label my axes, and I'm kind of squeezing in here. The y is the number of 1-hour classes. The x is the number of half-hour classes. So when I go to label it, or when I go to graph it, my m is negative 1/2. My b is 20, which my y-intercept is 20. That's going to be here. Now, as long as the x and y's are the same value, you can use your slope, even though they go by 5s, I can still use my slope the same way. Rise down 1, run over 2. I'm really doing rise down -5 and run over positive 10. So it's going to be 5 over 10, but that reduces to 1 over 2. So as long as they're the same units, you can keep that same slope and just use it with those units. Down 1 over 2, down 1 over 2, down 1 over 2. And I'm going to get my ruler. And so I have my ruler set up. Before I draw my line, I want to pay attention to, is it solid or dotted? Is it open or closed? In this case, it's going to be solid because of the equal bar. And from here, I could plug in 0, 0. But I could also, from the slope-intercept form, it's less than, so I'm shading below. Now the reason I'm not shading past the x-axis is because of the real-world aspect of it. I can't have negative hours. This is referring to the number of hour classes. So I can't have a negative number of half-hour classes. And it's just that real-world aspect that comes into play. So it's just shaded above the axis and below that line. So this is the last one. And if you notice, there's an absolute value. So you should know right away what the graph is going to look like. Because it's not absolute value, it's not going to be a line. It's going to be two linears put together to make that V. Okay? But I first have to describe the transformation, which is going to be shifted down 4. There's no dilation to it, stretched or compressed. And there's no shifting left or right to it because the x is inside by itself. So instead of my vertex starting at 0, 0 and the slopes being 1, 1, I'm going to shift my vertex from there, and it's going to shift down 4, and I have my point here. And it is going up because the a is positive. It's a positive 1. Doing my lines, and because they're linears, it is a slope on both ends, but they're both going up. And I can use my ruler and draw my lines. So there's my graph. And you can use the same trick that you did with the lines. This is greater than. You did need to pay attention to whether it was solid or dotted. And because this was equal to, it is solid. They are closed. So I did want to fill that line in. It is solid, which I drew it correctly. I just didn't mention that. But you do still need to pay attention to that. But going to the shading, it's either going to be everything on the outside of this graph or everything on the inside. Now, you can use the same thing that we did with the last one. Because it's greater than, the y is by itself. Again, to use this rule, the y has to be by itself. It's greater than, so you're going to shade up from the vertex. It's not always going to be on the inside of the V, but as long as it's greater than, you will shade up. I say it's not always going to be on the inside because if the A was a negative, the V would be going down. And if it's greater than, you're still shading up from that V, which means it would be on the outside of that V. So it's not inside or outside, it's up or down based off of the inequality. Why was the sun a little suspicious of the umbrella? Because the umbrella was a little shady.